We're going to go ahead and get started. This is being recorded, and so when I get a chance, I'll put this up on YouTube for everybody to watch. And so, okay, we'll go ahead and get started. So this is Aaron Murakami, and I'm here in Spokane, Washington. We have Peter Lindemann from out near Spokane, and Eric down in Tonopah joining live. Today is April 26, 2025. And last year, might have been early fall, I don't know, something like that, maybe 6 months ago or something. We had a live Zoom call with Peter and Eric, and we had planned on doing another call, which was going to be discussing the free energy research video from Borderland Sciences Research Foundation, which came out in 1987. And I guess life gets in the way, but we're finally able to coordinate this call where we'll go through some commentary on it by Peter and Eric, who were actually there. I think Peter filmed a lot of it, and Eric took part in some of these demos. I'll just give a couple quick announcements real quick. Um, so Eric, there's a nonprofit, EPD Laboratories Inc., which is a 501c3 nonprofit corporation down in Nevada. All donations are tax deductible, and the organization is for furthering the electrical sciences, headed up by Eric Dollard. And if you've seen my YouTube channel and the blog posts and a lot of the presentations and stuff, you know that there's a lot of interesting, Tesla related, high voltage, high frequency type of experiments, earth transmission experiments, and so forth. And this is all made possible by your donations. Eric's website is ericpdollard.com. And in the main menu bar, there's a donate link. And we can take donations by PayPal. You can choose to do a one-time donation or recurring, or you can send a check in. Checks or money orders. And Peter used to have a website, free-energy.ws, but actually you can still find it on archive.org. So archive.org is the Wayback Machine, which is the old Internet Archive. And if you go in there and you type in free-energy.ws, then you can see some of the content on Peter's website, which highlighted different inventors and different technologies, and that's still there and available for you. Also, over the years, Peter and I started these conferences again, which was the Bedini Lindemann Science and Technology Conference, something like that, in 2012, and it went by that name for a few years, and then it was changed to Energy Science and Technology Conference, just to be more kind of encompassing and more generic. And but it was back in about 2008 or so that Peter and I started A&P Electronic Media, which is on this website, eMedia Press. If you go to emediapress.com, there's over 200 books and videos there, and it's pretty much all original material. Not the copy and paste kind of stuff that you find out there. And the majority of the content is coming from the video presentations from the Energy Science and Technology Conference from 2012 to 2023. And so we took off the last 2 years from the conference. I'm going to be focusing on product development, and the goal is to be able to launch a few new products through the conference next year in 2026. Let's see what else is going on recently. I was recently interviewed by Greg Carlwood of the Higher Side Chats. He has a popular podcast, and that was done in Monday of this week, I believe. And so be on the lookout for that. The main newsletter I have is Energy Times. And if you join that, you can go to emediapress.com/Energy Times. It's free to join. And just about any update as far as products, books, presentations, these kind of calls and whatever else is always announced on there first. Also, recently, we've been upgrading stuff on the server. There's a new operating system. Been having some glitches. It's been like, 2 or 3 steps forward, one step backwards. But a lot of the websites are running a lot faster. We just upgraded EnergyScienceForum.com, which is one of the 2 forums. EnergeticForum.com is the other. But on EnergyScienceForum.com, if you log out or if you log in, with an account, it'll probably automatically log you out in about 45 seconds or something. It does it for the admins. It's in the admin panel. We don't know what's going on with it. And so if you log in, click the little remember us box, check box right by the login. That'll help keep you logged in. We're trying to work that glitch out. And I think that's about it. So we'll go ahead and get started. So with Peter and Eric, being that they were actually there and involved in the free energy research video, and little by little, I might cut to a screen share where I can show maybe just a, like a still shot excerpt in the video of the different stuff that we're going to be talking about. So Eric and Peter can kind of give a general overview of, what that day was like, what it took to put it together, why they wanted to put that together. Back in the day, Borderland Science Research Foundation is along the lines of kind of what we're trying to do with eMedia Press and a lot of the different experiments that we're doing and the conference and everything. And back then, they were really the pioneers getting these type of alternative sciences, the real Tesla technology, the so-called free energy, type of sciences out to the public. And if it wasn't for them, a lot of people today that's been following this stuff would probably have never even heard about these kind of things. So if you guys want to go ahead and just take it from there and kind of paint a picture of what this free energy research is about. And then after that, we'll go through each of the different technologies that you can, the demonstrations that you can comment on. And then we'll open up questions at the end. And if we unmute you and you want to ask a question, please make it relevant to the video and something that was actually in a video and not just about, free energy in general and that kind of stuff, but specific, to these, because this is going to be a good companion video for that 1987 presentation, which has, five different demonstrations. So you want to start it off, Peter?
Okay. Thank you. Thanks, Aaron, for throwing all this together. Okay, so yeah, I just looked at the film again this morning and just went through the whole thing. I first met Eric at the Integratron about 3 years before that film was made. And that's where he was demonstrating his big magnifying transmitter. And I brought a camera out. That was a long haul drive from Santa Barbara at the time. And so he and I had sporadic contact through Borderlands since that time. Some funding came through from a Mexican investor, which started the Santa Barbara laboratory. And then Eric started kind of coming to Santa Barbara a lot, and so that's what was shown on the film was that was the first in the series of things. But I think at the end, Eric shows the big cosmic induction generator thing. When that got operational, then things were pretty amazing. But this was the first kind of blush of experiments that Eric had been doing recently, that Mike Knox and I had been doing recently. So we thought we had enough. We wanted to document some of these things, and we wanted to say that it had something to do with free energy. So I think the idea of just calling it free energy research, which is really what it was, because there really didn't show anything that was truly more energy out than in, but it showed the kind of experimentation that we hoped to interest others in doing, which is fundamental research, basic experimentation that, hadn't been done by others before or hadn't been reported by others before. Pretty much most of what was shown there were unique and, untried arrangements. We were looking into every kind of electrical induction, and that wasn't, a standard, just, a wire moving in front of a magnet. We were looking at, which is, Faraday's, direct induction. We were looking at every other arrangement that we could think of to produce, the flow of whatever the heck electricity is. Even Tesla said it, that the day we discover what electricity is will be the greatest day in human history. And he didn't claim to ever know exactly what electricity was. So we were just following along those lines. Eric, you want to have some opening comments? You were in almost every sequence in the film.
Yeah.
None of this would have happened if Eric hadn't been there. He's the one who showed Mike and I how to test all the stuff that we'd built earlier and everything. I mean, in the early days, Eric obviously was the one who knew the most. But that didn't stop us from trying crazy stuff. Go ahead.
So, yeah, everything leading up to this would be worthy of a Hollywood movie. And it's very lengthy, but basically, most of this got, how would you say, initiated, this interaction got initiated by my efforts to assemble the Integratron. And as Peter Lindemann had pointed out, he had come out there. A lot of people were starting to come out there when they heard about me, and we were actually assembling the Integratron. Van Tassel had died several years beforehand, and then a person by the name of Donald Lockwood had acquired the thing, and then by essentially supernatural set of coincidences, he had run into me when I was rebuilding Navy ships in San Francisco, and had done something at the Richmond shipyard when I was the electrical engineer there that freaked out Pacific Gas and Electric, in that I was experimenting with my mathematical research and the immense power flows available to me at the shipyard. And I had tripped the reverse power relays at the Richmond substation and knocked the town of Richmond off the grid, which meant that I was generating more power than I was consuming, and possibly more energy. The power company really wigged out, and everything got kind of stirred up about that. And so that was about the time that I started getting involved with Don Lockwood. And then he was telling me about this thing he had out in the desert and the space people. And I didn't want to hear any of that, because I'm a pretty conservative electrical engineer and I don't want to hear about space people. But there was a physical apparatus. So an event occurred at the shipyard that major sabotage had been committed to the electrical system there. And I was the one that discovered it, and that turned into quite a conflagration. And I had to flee for several years. And so the continuation of the source of food and beer and what have you was Don Lockwood, so I moved to the Integratron. And that went fairly well until the usual Commonweal forces took it away from us. And not only did they take it away from us, but they were attempting to strong arm my laboratory. So I had somebody, I forget what his first name was. His last name was Fueling, and he was doing engine research for General Motors, I believe. involving some kind of acoustics, and he showed up with more firepower than the opposition, and there was an armed standoff, and we moved my laboratory to Santa Barbara, which resulted in a whole different set of complications that finally got hashed out. So basically, my organization, so to speak, was myself, Donald Lockwood, and David Franklin from San Francisco, and in Santa Barbara was Peter Lindemann, Michael Knotts, and Chris Carson. And we had been interacting prior to the removal of my laboratory to Santa Barbara, but when the laboratory got moved to Santa Barbara, then that led to this video. So the principal effort involved was I had started to get involved with Borderland in its third generation under Tom Brown, and Tom Brown and myself had decided that we had to get rid of all the evil spirits and voodoo and incantations and all the dark, creepy stuff that Borderland had immersed itself in, and get into the scientific end of it, the principal thing being the Lakosky MWO, which Borderland had basically brought out from oblivion at its inception in the 50s, and debunked this whole free energy carnival, that's exactly what it was. It was a complete carnival, and nothing was really being produced. It was all basically just promotional stuff, which it still is to this day. Nobody has ever produced anything even nearly resembling free energy, even though millions and millions of dollars have been spent.
Hundreds of millions.
What's that?
Hundreds of millions.
Hundreds of millions of dollars have been wasted, and lots of hype, and me being kind of a nasty, disruptive personality, teamed up with Tom Brown, we were quite offensive about our disruption of the whole thing, which entertained us and sure did not win favor with many of the so-called free energy people, but did attract the attention of somebody by the name of Josh Reynolds, and he had financed me to the point where I was able to establish some level of laboratory in Santa Barbara. So the principal thing in Santa Barbara was what I believe you guys called the variable reluctance machine. Is that correct?
Well, that was just one of the
But that in particular.
Yeah, that was one of the machines that I
Yeah.
had been working with from building on the work of a number of other inventors. So that was definitely one of the things.
It's my understanding that an immense amount of machining went into that, and if I remember right, that you had basically put $25,000 of your own money into that effort.
Over the years, absolutely.
Yeah.
That and in between the number of hours and everything else that Mike Knox had put into the machine work. I mean, he was a class AAA machinist for prototyping, and he even today he's the only person I know can look at a prototype job and actually come up with the right number of what it's going to cost to produce. Everybody else, figures out something and then triples it and hopes they're still, under. But, he's the only one who can actually tell you exactly what it'll cost and then come in under budget. So, I mean, brilliant, machinist and engineer.
So seeing that machine, that immediately connected my mind to what I was doing with my Steinmetz research at the Richmond shipyard. And I became quite interested. It was a 4-quadrant apparatus which tied in what was going on in the Integratron and what was going on in the shipyard and what was going on with Steinmetz and the whole thing. And so I felt that was something worthy of my attention. So what I did is all the free energy charlatans, the little digital things and meters and all that, and they don't know how to measure any of this stuff, and they don't really know anything about electricity or what have you. So the whole thing had just completely drifted off course. So I decided to duplicate what I had at the shipyard, is where I used the electrical switchboards out of the engine rooms of ships with all the power factor meters and watt meters and the whole thing, was to analyze this machine with legitimate instrumentation and attempt to unravel all the energy losses and gains and what have you, and come up with an accurate quantitative analysis of what was the energy balance of the machine. And the conclusion that we reached in this video, which demonstrates that effort, was, first of all, the machine, for something with the amount of magnetic leakage and what have you that was involved in its construction and operation, was remarkably efficient. And in estimating the losses and the gains and what have you, the thing was bordering around 100% efficient. And in my mind, that served to verify the things that Steinmetz had brought up and what I experienced at the shipyard with the power outage and many other things that were going on there. It's like opening up the main circuit breaker in the engine room of a ship power plant that I constructed, and the lights staying on that earned me the name of the wizard, not alone knocking out the power to the city, but I felt that machine held promise. And that kind of got me married to the situation in Santa Barbara, particularly being that the cosmic induction generator that Don Lockwood and David and myself had built out in the Integratron was being powered up to about 3 or 4 kilowatts. And unfortunately, the stunning effects of that were never, well, they were recorded, but they were lost. So one thing I want to point out, I see a lot of comments, oh, the video's lousy, you people this, you people that. Well, the video's lousy because the people that were entrusted with the custody of this material had jettisoned most of it. And almost everything that I had done up to that point was lost. And there's virtually no evidence of anything. Presentations I gave, videos that were made, the extensive written material from my research at RCA in Sonoma State was all lost because some people wanted it lost. And it was not the government, it was not the men in black or any of that kind of stuff. It was just the normal greed and delirium and things that actually are very widespread now. You can go on YouTube and just see hours and hours of delirium and insanity and misinformation, and now it's a societal norm. So
yeah, you can barely tell the difference. Just a little bit more on the quality of the film. I had an original copy. It started as a VHS in 1987. It was recorded in VHS, and that thing sat on my shelf for 30 years before Aaron and I had the idea of reproducing it. At that point, it was digitized, and so 30 years of a VHS sitting around, there's a natural degradation. Just from the embrittlement of the tape and all kinds of different stuff. So the fact is, and then of course the link that Aaron gave to the hijacked version on YouTube is probably a copy of a copy of a copy from a digital degradation as well. If you'd watched it from the original digital system product that we sold through A&P called what was it, Classic Energy Videos, I think it was, the whole product was called. The quality's 20 times better than the free YouTube one. Just to address the mechanics of signal degradation on that. But anyway, go ahead,
So
Eric.
that serves as the introduction. So I guess let's move forward.
Yeah,
Okay.
Aaron, where do you want this to go?
So I have a little bullet point list here of everything that's in the video as far as the demonstrations. And so just a quick, I'll just run through these real quick, and then we can just maybe just take one and you can kind of comment on it. I can do like a screen share to at least show that part of the video. And I'm also going to have to take this laptop upstairs. There's going to be a machine running, and I don't want it to get noisy on the call. So the first thing that starting off in the video is Eric does an intro on electricity and dielectricity. And then after that, Eric does a demonstration of two types of spark gaps. Like
Discharges.
Energy discharge.
Oh,
Yeah.
discharges. And then after that is a rotary parametric transformer, which is the variable reluctance machine that Eric is talking about. And then after that, there's a solar panel impedance matching demonstration, I think by Tom Brown.
No, that was with Eric.
Oh, that was with Eric? Okay.
Eric did that. Yeah, pretty much.
And then after that, Peter and Mike Knox does the demonstration of the AC homopolar generator.
Yep.
Which is a very oddball thing. And then at the end, Eric does some continuous wave discharge with like a flame speaker, burning these patterns into wood. And I think he does some of the cosmic induction generator demonstrations.
He also did some demonstrations showing that the propagation of waveforms through these types of coils can exceed the speed of light and all kinds of other things at the end too.
Kind of like in the longitudinal videos.
Yeah, there's two companion videos to this that deal with the Tesla transmission, like to the beach, and then there's an auxiliary one of me in the RCA antenna field, which is unfortunately another low resolution and what have you, where I was beginning my study of the Alexanderson system. So, which is another massive story behind that video that is just completely mind-boggling. But at any rate, we're not in Hollywood right now, so.
Yeah, I'm going to show a screen share real quick of Eric's site. Some of these videos he's referencing. Do you see Eric's website? Did that come up?
Yep.
Okay, so
Sort of.
on Eric's website, in this main menu bar, here's the donate link, by the way, if anybody wants to help support the work that we're doing with EPD Labs Inc., this is where to do it. So over here, there's a free link, and if you just put the mouse over it and bring it down and put the mouse over videos, there's the history theory of electricity. I think it's history theory and practice of electricity or something. Here's this RCA history of Marconi video, or origin of energy synthesis. This SBARC, like a ham radio kind of convention thing where Eric and Chris Carson are presenting the Tesla Marconi wireless system, and then these transverse and longitudinal waves where Peter's mentioning the propagation speed exceeds, the so-called speed of light. That's demonstrated in these. And so part of that kind of demo is in the free energy research video, you're saying?
But those last two there are the companion videos that came out with free energy research, or they were the next two that came out. They came out in 1988, whereas the first one was in 1987.
Okay.
But those are the ones that Eric was referencing.
So then in the video, this is on my YouTube, or this is YouTube page, but it's in a blog post that I put on eMedia Press. But you can just type free energy research into a Google search bar, and this one will come up, or another one that, other people have posted. So in the beginning of it, looks like Tom Brown is doing a demo. I'll turn this audio down.
He's just introducing people in the room.
So besides everybody doing the demos, there's you said Steve Ellswick from the Tesla Tech conference, or who does Tesla Tech conferences now, and Chris Carson are the other two people there. Is that
Yeah.
Steve Ellswick in the middle?
That's Steve
Yeah.
Ellswick, yeah.
Okay, and that's
Right
Chris
next
Carson
to
to the
Mike
right.
Knox there, that's Steve Ellswick, and then that's Chris Carson.
Okay, Mike Knox, Steve Ellswick, and
Chris
Chris Carson.
Right there in that shot.
Okay, and then Tom Brown's just kind of narrating, doing some
Right.
intros,
I'm
and then
behind the camera, and then next to Eric on the far side is Dave Franklin.
okay, and then this dielectricity, magnetism, electromagnetic induction. This
Yeah.
obviously in the video for anybody to see, but do you want to kind of give explain why this is in the beginning of the video? Kind of what this is about, and while you're doing that, I'm gonna mute my video out, and I'm gonna take my laptop upstairs to where it'll be quiet, so this
Okay.
machine doesn't bother you in the background. So let me stop the screen share and okay, go ahead, Eric or Peter.
Well, let me.
Well, I mean, Eric did the demonstration there, but I
Yeah.
mean, from my point of view, as someone who was watching it at the time, this film was about the research that we were doing, and I think we decided to start with something that was real, and essentially classical, supposedly classically understood. So, in other words, if we're going to be talking about free energy machines that are supposed to be producing electricity in novel ways, which a lot of the experiments we show are, we thought it was smart to start at the beginning, and that is define what electricity is to the best of our knowledge. And so that's what that first sequence is.
Yeah, basically, I was picking up out of Steinmetz's books. I think it's discharges, waves, and impulses that shows the difference between electrostatic and electromagnetism. And it was my belief, if there was to be any creation of energy from so-called nothing, it would have to happen in electrostatic units and not electromagnetic units. In fact, actually, I still tend to hold that feeling to a certain extent, but there hasn't been much research going on in that, other than we've started with the Trump machine,
Right.
which was built by Chris Carson at about this time from our efforts to analyze the integratron, and I felt that would possibly be a so-called free energy machine, but at any rate, I think I pretty much adequately demonstrated in this video that the electrostatic forces are much more, they're profound compared to the electromagnetic forces. They tend to be regenerative and extremely powerful, self-sustaining, in that a capacitor will stay charged for almost indefinitely, but an inductance coil, no matter how hard you try, the energy, magnetic energy, is just dissipated in the heat. And there's no way to really capture the energy perfectly without superconductors or, things that are physically unrealizable in a simple laboratory demonstration. So I wanted to get that out of the way to show in the beginning of the video what the constituents of electricity are and what its various manifestations were, to kind of establish the language of electricity to be used in the video.
Right, and also to establish the high bar that we weren't going to pull any wool over anybody's eyes, and we were going to hold ourselves to account to facts and reality. So I think that was the whole purpose of it. So I thought there was a as far as I could see, it was a brilliant opening sequence of setting the standard of zero bullshit.
It's the things that you never learned in college.
Exactly.
The most
So,
important facts that were left out.
Yeah.
Which is so evident today that there is no longer any comprehension of even the most basic principles of electricity anymore that haven't been thoroughly adulterated by the physicists. And what's happening to the electrical utility system is a horrid example of how far this thing is going, and it can only lead to an absolute catastrophe, but there's nothing we can do about it.
yeah, we can watch.
Watch,
Yeah.
yeah. You listen to it, jam out our radios, see the massive blue flashes of fire when something goes wrong, and the massive forest fires, and there's plenty of after effects, but
Yeah, really, yeah.
nothing will change.
Really, the rumors after the fact are going to be great.
Yeah. Well,
So,
one thing that will change this week, and rest assured that it will get worse.
Yeah, because that's the demonstrable trend. So okay, so yeah, the next experiment that was done was based on the what was being called the variable reluctance generator. That was actually the third iteration of what Mike Knox and I had been working on. We started with a much simpler operation between the 4-quadrant devices, and the one of them was that had a commutator on it that would just connect adjacent poles, so that two of the sides could be input DC, and then the other two could be output AC. And then that was one of the configurations. In that same configuration, then the inputs could be just permanent magnets rotating. And then in the third configuration, we added the 5th coil, which is the one we demonstrated there, where all of the external coils, were electrical inputs.
Is this the correct section in the video, Peter, that you're
No,
referencing the coils?
no, it's a little bit farther
ahead.
along than that.
Yeah.
Past
That's
that, or
still part of the first demonstration. Farther along, yeah. There. No, keep going. There. Okay, if you go back.
Now, one thing I want to point out before I forget,
Yeah.
and this is very important, is, and I observed this in other so-called variable reluctance situations, that even though you can't say that this machine is producing more energy than it's consuming, even though it intimates that it's happening, one thing that is definitely happening, and this can be measured with actual watt meters, and I had done these experiments when we first got together, when Michael Knotts had the laboratory in the backyard shack, if you remember.
Yeah.
And with the neon sign transformers, which have a saturating core in them, and I had left the neon sign transformer open circuit, which is not a good idea because it's a constant current device. It'll just keep generating voltage and burn itself out. But they are made to operate that way shortly. The watt meter had indicated that an incredible amount of energy was flowing into this thing, which without any output would have melted the tar and smoked the thing out. And so the law of conservation of energy was violated. This thing was soaking up energy, and there was no heat, there was no light, there was no noise, there was no motion. And I observed the same thing with the variable reluctance machine, in that this thing, as a motor, would pull like kilowatts off the line, not kilovolt amperes, but actual energy kilowatts. But there was no load on the motor, and there was no heat in the windings. So we did succeed in demonstrating that the law of conservation of energy can be violated, in that maybe we weren't able to create energy, but we were able to destroy energy. And that's enough to indicate that it's worthy to carry this line of research farther.
Well, and it represents, the supposed laws of thermodynamics say, that energy cannot be created or destroyed. So the fact is that if you can do either, that means you've got an open door to somewhere else.
Exactly.
Yeah, and so we from the basic understanding of what we were trying to do, we knew that we were already in the ballpark, because we could clearly see the energy destruction events. Those were very demonstrable, especially with no heat generated. Even when we're producing electrical outputs and things like that, the machines ran cold. So there were a lot of things like this that were clearly. I mean, we commented. I mean, what was going on at the lab? We probably commented on 2% of what we were working on in the lab with that film. That's the other thing that most people don't understand. There was just no way. We'd have to be filming almost everything we ever did to have documented what happened at the lab. That this was a sequence of highlights that we felt were sufficiently demonstrable to document. So.
Yeah, and I have been experiencing this all the way back into my childhood, with my high school involvement with Radio Corporation of America, in my own laboratories, and Steinmetz writing chapters on this subject where, he would say that this is like a complete anomaly. Tesla making comments about electrostatic generators, saying that, this questioned the law of conservation of energy, which he was a hard adherent to. Tesla was not a free energy zealot by any means.
So all of his free energy systems were attached to a hydro dam or something like that. I mean, he believed in that all the energy that he was going to process through his systems came from the environment. He didn't think it just appeared out of nothing.
No, in Tesla's mind, this was, it had to be trackable somewhere. Heaviside called it the law of continuity of energy. That's a better way to go about it. But my experience, and then also the work of Philo Farnsworth, which I had direct access to, Farnsworth building tubes that once they were energized, they tend to self-power themselves. And, mathematically speaking, out of the virtual cathode, there was more electrons leaving than were entering. Well, where are those electrons coming from? So Steinmetz is showing that, that electric arcs, which are nonlinear, resistances over a cycle, are making energy vanish into some other coordinate system. And so this is not harebrained stuff, but in order to actually get anywhere with it, if you don't have GE laboratories, or you're not, in the Bell Telephone laboratories or whatever, you can't do this stuff other than, piecemeal here and there. And then all of a sudden, just by the time that you're about ready to make some progress, the funding gets cut off, and, the rats run for the bushes and everything goes to the dump. I've been through that too many times. But the validity is there. It's concrete. It comes from reputable sources like Steinmetz, and out of organizations like Radio Corporation of America, great names like Farnsworth and all of that. There's definitely a lot of things that can be studied and analyzed, but this is not something that society is interested in. And then on the other hand, you had all the free energy charlatans, led by Tom Bearden, and I won't mention some other names because of conflict of interest, but you know who I mean. And that just muddled everything up even more until now, Now the name of Nikola Tesla is Elon Tesla, and all it represents is a political lizard pit, and that's the end of it.
Okay, so we can go into the variable reluctance machine if that's of interest to anybody. The solar impedance matching circuit was another sequence. We only proved that in this film that that energy could be improved. The energy transfer from a solar panel to a battery could be improved by impedance matching. And one of the other sequences that we did that wasn't on the film was we ran some very, very simple experiments. That's not from the original film there. One of the sequences that we did was we just put together a 555 timer running a relay that would switch about once a second. And so then we'd let the solar panel charge a capacitor, and then we dump the capacitor into the battery and just flip, flop, flip, flop, flip, flop. And by just doing that, we could get twice as much energy into the battery as we could if we just put the solar panel on the battery. And that was a fantastic, simple demonstration because the capacitor wants to charge, with voltage, which is what the panel wants to produce. And then when it's short circuited across a battery, which is basically, I call a battery a short circuit with a voltage displacement is really what it is. It's not a load of any kind when you're charging it. And that's perfect because the impedance of the discharging capacitor is even lower than the battery. So I mean the delivery of amperes in that situation is huge, which is exactly what it wants to see. So that little arrangement demonstrated the principle really, really well. So of course it also ate up the relays, but it just shows you that the switching method was not complicated. But again, this is 87, so didn't have high power MOSFETs and that kind of stuff in those days. But anyway.
Well, that brings to mind something I want to point out, that electronics is actually kind of antithetical to a lot of this electrical work. In fact, the ultra heterodyne receivers that are being developed here for the seismographs and a lot of the ELF stuff, you have to use mechanical commutation. You can't use semiconductors or any of that kind of stuff. And that's why Tesla was able to do a lot of things that can't be duplicated, because he was doing everything electrically and not electronically. And that was the big challenge for him. How do you amplify electrically? You can't amplify electronically. In Tesla's age, there was no tubes or transistors or...
There wasn't even a diode.
No, there was nothing. It was all motors and generators and transformers. That's all you had.
Yep. Yeah, he produced miracles with no tools at all. So, yeah.
That's why people get these ideas. Oh, well, we'll make some improvements here because we know better now. No, don't work that way. So this is another factor to be taken into consideration when doing these type of experiments, research.
So, okay, so we're an hour into this, Aaron. Where do you want to take this?
So you mentioned the solar panel. I actually couldn't find the solar panel part in there, but the
that's because it was really just a quick discussion and one test by Eric showing the impedance matching process.
Yeah, what I attempted to demonstrate was how the characteristic impedance of the solar panel varies with the amount of sunlight. So there wasn't any apparatus or anything involved. That was
right.
I just wanted to show that, that it's not a definite impedance. It varies. So as the intensity of the sunlight varies, the ratio of the voltage to the current that the solar panel is connected, the load that the solar panel is connected to has to vary accordingly in order to maximize the energy
transfer,
capture.
right?
Yeah.
So then after that is the AC machine. So that's based on the Faraday homopolar generator that he, I don't know, 100 years ago or whatever. And since then, there's a handful of names involved with different variations of these type of homopolar generators, which I believe are mostly DC. And I think Faraday was using like permanent magnets, and then later people like Paramahansa
Paramahansa Tawari, yeah.
Tawari, Bruce De Palma, and what's his name, Peter? The third guy.
Oh, Dasgupta?
No,
Or who?
it was somebody else with these homopolar generators, and I think most of those magnets were electromagnets. But in any case, all of them are showing this over, 1.0 COP performance. And of course, you knew Bruce De Palma, and you worked with him for a long time, and he was one of the pioneers of the end machine kind of variations. Most people have just stuck to very simple demonstrations with the magnet, where it's like tapping electricity out of space or whatever. It's kind of an interesting thing, where if you have a rotating permanent magnet, for anybody that doesn't know, because I've done a number of these experiments with just permanent magnets, is if you got a conductive magnet, these neodymium magnets got like these nickel coatings or whatever, and they're conductive, and you have a shaft in there, and you rotate this magnet at high speed. If you got a brush on the outer perimeter of the magnet and a brush on the shaft, you get a voltage difference there, and you can actually get power out of that while that magnet is spinning. There's no coils.
There's no inductors involved. That's right. That's the big deal. In other words, there's no coils, there's no impedances, there's no inductance essentially.
Well, basically what's going on is the induction now is occurring 90 degrees displaced from what is conventional. And so it's an anomaly that basically defies, physical analysis at this point.
Right.
But it does work. Now, I don't think it generates any energy from nowhere or what have you. None of these things really indicated that, on the level that they'll put out more power than they put in, but they open up another avenue.
Well, the thing is that when you take power out of one of these devices, it doesn't produce the standard commensurate anti-motoring effect. So in other words, that's the reason why people have said, that it can produce more electricity than it takes to turn it.
Yes, but that's the error in that is like with the neon sign transformer. The neon sign transformer, our electrical technology is what's called constant potential. In other words, the so-called voltage is held constant. Now, if you keep decreasing the resistance or increasing the conductance to the point where you reach a short circuit, well, that's a fault condition because it's trying to maintain, a constant voltage across the zero impedance is going to result in catastrophe.
Well, infinite current flow.
Yeah, but there's also the inverse, and these are the things that I was trying to demonstrate, possibly in the beginning of this video. I don't remember, but there's the constant current systems. Now, they used to be in widespread use for street lights. It used to be you hooked all the lamps in series, and that was very economical on the copper because you just had one wire loop. You didn't have, bus bars basically tapping off. You had a 6.6 amp loop that ran all up and down the boulevard, and each of the lamps was about 60 volts, but the thing is they would all add up to about maybe 6,000 volts worth of lamps. Now, what would happen is if one of those lamps open circuited, Well, the supply transformer, the ballast, so to speak, would keep increasing the voltage to try to maintain the 6.6 amps, and the cosmic inferno would break out inside the light bulb. So they had to develop a kind of a counterpart of the fuse, which basically melts and open circuits the short-circuited constant potential system, and it had a semiconductor disk that was in the light socket, and if the bulb opened up, it would fuse together and short that bulb out. And then when you pulled the bulb out, you replaced the disk. Those systems don't exist anymore. But so basically, if you have a rotating machine that's a constant current machine, and if you short that machine out, it takes the load off the prime mover.
Right.
But if you open circuit it, then it just lugs the thing down like crazy and fire erupts. So
And
basically,
that's what the variable reluctance machines did.
yeah, it was doing the same
They
type of
have
thing.
this inverse function.
So that does not mean that you're getting free energy, and that when you put a so-called load on the machine, you know, that it unloads the prime mover. The thing is, if you match the characteristic impedance of the system, either way, there's going to be a point where the prime mover is going to be delivering the energy to the load, efficiently without, any speeding up or slowing down or so. These things were never understood by any of the free energy vaudeville actors and all this type of stuff. Just because you take the light bulb off the machine and the prime mover speeds up and becomes unloaded, or when you put the light bulb on, it speeds the machine up. That's all basically a matter of, constant impedance versus constant potential, and does not mean that you're getting any free energy.
Right.
And that's something I was never able to really get through to any of these people, because, they wanted to believe that it was free energy, but it's not. And like I say, out of all the talk and this and that and this motor and this thing and this deal and all that, there still is no free energy. Where is it? People have to ask this point, how many years it's been? This stuff all got cooking, back in the mid-70s.
Right.
Where is it?
Well, I mean, it's definitely not available commercially, but I think there's commercial reasons for that as well. But we've demonstrated, that there's plenty of anomalous phenomena that could be engineered to create a higher level of efficiency than is generally available.
Well, the bottom line is, okay, from the standpoint of the law of continuity of energy, there's two ways you can go, okay? Can you synthesize energy from its parts? Right. That's what the variable reluctance thing intimates. That's what Steinmetz equations on the variable reluctance machines intimate. Is it possible to synthesize energy from potential? Of course, physicists say, well, that's just gobbledygook. Well, who cares what they say? It's just a bunch of abstract theories that now are so convoluted they have no contact with reality whatsoever.
Right.
So the other thing is, okay, well, energy transferred from one system to another. Okay, well, this planet that we're sitting on so peacefully and calmly, and everything is so still and stable around us, is hurtling through space millions of miles per hour. We can't even fathom it. Now, if I was to take my ballpoint pen and throw it off the train, okay, and have it hit a tree alongside, that pen moving at 1 million miles per hour would be an absolutely devastating blast.
Right.
So that energy is sitting here. So what Tesla was kind of leaning towards is, where do you find the absolute or cosmic ground, the thing that the Einsteinian relativists, find most revolting, is that absolute point of reference, and that's what Tesla had started to tap into, was what if you can connect one terminal of your light bulb to cosmic ground, and then connect the other terminal to what ain't grounded, which is what's flying through space, and cutting lines of force and doing all kinds of things at incredibly intense levels.
Right.
But I would be rather careful about trying to pry that can open, because if it got out of control, there wouldn't be anything left.
Yeah, I mean, I think this is one of the things that, clearly Tesla was always attaching his machines to two places in the natural environment, not just ground, but to an elevated capacitance and some other. So he was always expecting the natural world to produce the potential in his machines, so that he didn't have to do any work to do that. And then the device would simply produce power in relationship to the size he built it. And that's, so all of his, big magnifying transmitters and stuff were tuned to pick up, the standing waves that were generated by lightning all around the world and things like that. So, he was, that's, the idea of free energy isn't that we can, build a quote perpetual motion machine that doesn't have a source of energy. That's all just nonsense too. But that the fact is that the environment is the source of all energy that we've ever had access to. And I mean, even an oil well is free energy to the guy who drills the hole in the ground. Because he can pump oil out of that for years and years and years, and the earth isn't sending him a bill for it. So that's the point is that the environment is the source of energy that we're supposed to be tapping. And the question is, if you only attach the machine to one point in the environment, then it can't provide a flow. So that's the whole point. That's the difference between all of these different systems and what Tesla was trying to do. So
yeah, it's the open versus the closed system.
Exactly. It has to be an open system and attached to two different potentials at the same time, and that energy flows, right?
So we should maybe focus on the homopolar generator just a little bit. And one thing that's good about this is that most experimenters can experiment with this concept because you don't need a background in electrical engineering or anything. It's literally something with magnets rotating, and then you're getting something off of it. And it's easy for, anybody to kind of experiment with it. The level.
Well, it's actually not that easy, because you've got these sliding contacts, and 99% of the energy is soaked up by the machine. You've got you've got an electric motor turning the thing, and 99% of the energy that's consumed by the machine is the brush friction and the windage and everything of the electric motor itself. I've recently built apparatus within the last year that re-verified all those experiments, and we got and we're able to actually take the output and put it through a transformer and get 80 volts AC on an oscilloscope, coming out of the transformer. We took a microwave transformer, took the low voltage coil out and put 2 turns of 1/0 wire, and then just took those butt end things and put them right on the disc, two shaft positions of the disc, and was able to produce 80 volts AC directly off the disc. With
light anything up?
What?
Did you get
it didn't hit. I mean, the disc was even smaller than the one that we tried.
But I mean, the 80 volts, did it light up like a light bulb or heat up?
Yeah, we could have run some LEDs and that kind of stuff off of it.
Okay.
But, right, we were, but we could bury, I also got some AC amp meters, and we could bury a 30 amp meter with it too. So it definitely had current, it definitely had voltage, and it definitely didn't load the motor. Whenever we took the power out of it, it didn't slow the thing down at all. So,
So it's probably worth mentioning, the significance of this is that this homopolar generator business is that it'll put out current, but there's hardly any voltage. So people,
right, it's,
well,
the ratio between voltage and current is 1,000 to 1 or
ridiculous.
something
Yeah.
crazy, yeah.
So the voltage is not, hardly even there. So people are wondering, well, how do you get it, get the voltage up? So back in 87, when they're doing this experiment and doing an alternating current version of this, well, if you have a sine wave which is changing like this, that means you can put it into a transformer like Peter is saying, and you can up the voltage.
Right.
And that's significant because before then, I don't know of any references that anybody has ever done an alternating current version of these in order
Right.
to get transformer action out of it.
Right.
So that's the first. And
But also the transformer we put it through had a huge iron core, so that proves that there's, that we're magnetizing the core to get anything out of the isolated winding. So the point is that the current was there, absolutely.
yeah. So
Yeah, because I mean, you can get some electrostatic stuff going on in an air core, but the only way to get something through an iron core is pretty much you got to magnetize it. So yeah. So anyway, the method that we used with the new device, we bought some ring magnets, the neodymium ring magnets, and we just laboriously took a diamond saw and just sliced it into 2 halves, and then just flipped one of them. And we did this to two donut magnets, and then we just so had one half of the disc was north to south going through it, and the other half of it was south to north going through it, and just glued all that crap onto the copper disc, and spun it up, and put brushes between the inside of the donut and the shaft, and that's what we got. And it was 1 cycle per revolution, but it shows that.
Is that what's in the video? That particular setup?
No, we don't have any video of what this is. This is an arrangement that I
later. Okay.
Yeah, I did this last year.
Okay.
Okay.
But it's the same thing as is in the video.
Yeah, that just shows 4 rectangular magnets, and those were ceramic, magnets. And that was only on one side of the disc too. Those magnets were only on one side of the disc.
Okay, so basically you took it to the next step.
Yeah, we took it to the next step. We wanted to re-verify that there was real currents and stuff like that, and because we had assumed that we could transform the voltages, but we had never actually did that on the initial video. And all I'm saying is that I've gone back and re-verified that every speculation that we made in the video about what was possible with that arrangement is now established fact.
So about 6-7 years ago or whatever, the only I've done a few, some experiments with this end machine business with rotating permanent magnets, and the only other way I know of how to get the voltage up, I did a little presentation called the high voltage end machine.
Yeah.
Kind of a goofy little machine, but what I did was I took one of these neo cylindrical magnets on a shaft. I had a little brass flywheel on there, and I spun it up with the remote control car motor. And then I had the brushes, little copper strips on the perimeter of the magnet and right on the shaft. And of course, you get the expected almost no voltage and some current. And so what I did was I commutated it on the magnet, and starting off with putting electrical tape and little strips periodically around it.
Yeah. All he made the thing do is so he just let the brush bounce.
That's right.
That was it. And that works too.
And so I commutated the brush around the magnet, and then the 2 wires, I had those going out to the input of a low resistance performance ignition coil, like 0.3 ohms or something like that. And so as it's commutating the output of the magnet into the input of the primary of the ignition coil, the high voltage step up would charge a capacitor up.
Well, did you have a diode on that?
What's that?
Did you have a diode on the output of the?
I did. Yeah, I had a
Yeah.
diode on the positive.
Yeah.
And then the high voltage output, yeah, I think I had a full wave bridge actually off of the ignition coil with
Right.
one N914 diodes or something. I can't remember what it was. And so then I had it going to a little pulse capacitor. And the capacitor, and then I had a little NE2 neon bulb in parallel with that pulse capacitor. And, you know, those trigger at like 90 to 110 volts ballpark, something like that. And so as soon as the capacitor would get over to the flash voltage of the neon bulb, the little neon bulb would blink, and then the capacitor would charge back up and it'd blink. So here's this neon bulb blinking at about 100 volts, just going deep, 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 proving that you can get high voltage. And so I think it was the first time since Faraday invented the thing that anybody blinked anything as high as a neon bulb directly off of a spinning magnet. And there's a stupid little commutator version that I came up with. And then what I found out was I removed all the little strips, and because these strips were in kind of bad shape, just the brush noise alone actually commutated and pulsed the output of the magnet into the ignition coil better than the commutated version. And so just by having that noise on there, the zzz, as the magnet's spinning, worked even better. So it's kind of interesting that Peter's behind the AC one, and I came up with a stupid little commutated.
Pulse DC. But I mean, the point is that considering that, you know, Faraday discovered this in 1831, and some of the best minds in the world, including Tesla and who knows else, you know, never figured out how to get anything other than flatline DC out of it. Duh. I mean, it's like people's the real holdback in this whole field is a lack of imagination, unwillingness to just try something silly, and because it's startling, to think that a bunch of unfunded lightweights like Aaron and I figured this out where everybody else failed. That's crazy. Sorry.
So let's see, we're at an hour 27 minutes. Maybe we can touch on a few minutes on the final demo that Eric did, which was doing some of these discharges, burning these patterns into the wood, some of the cosmic induction generator bulb and the flame speaker. And then after that, we can take maybe up to a half an hour of questions or whatever. Let me do a screen share real quick just to show the section in the video. That'll be the last demo in the video. I think this is going through the AC homopolar setup right here, and then
keep going.
With Peter and Mike Knox, and then it gets to the final demo. So here's Eric.
There it is.
I guess setting up the. I don't know why it keeps showing these commercials. I disabled the ads and it keeps showing.
Because you're using a commercial.
So anyway, yeah. So I'll skip through the ad while maybe Eric, if you want to kind of talk about the setup that you have there and the different demos that you're doing with that at the end of the video.
Yeah, I think that was basically like a very small model of the larger cosmic induction generator. I don't know exactly what I was after in that, being that was so long ago. And I guess the big one wasn't quite set up yet, so it might, like I say, that was so long ago, I don't remember the details. If I remember right, Chris Carson and myself did some demonstration where we had transmitted DC through space electrostatically, like the Tesla, what did he call them? His beam tubes. I think that was towards the tail end of this video. There are
I
so
just
many.
watched the whole thing this morning and that wasn't in there.
Wasn't in there?
No. Well, when you were sparking some stuff off of a big tower of capacitors and stuff, and you had a bunch of non-conductive strings that were dancing along, and when he would discharge it. But that does demonstrate, and then you explained that that had to do with what a dielectric discharge is. It isn't something that's erupting from the thing. It's something that's coalescing out of space.
Well, I particularly remember that we had videoed something where we were transmitting from one dark discharge in a gas tube to another dark discharge in the gas tube, but that may have gotten edited out.
Yeah, that wasn't in what was available through this, and also this didn't have the final sequence where we actually transmitted down to the beach either.
No, that was the longitudinal one.
Oh, that was that one. Okay.
Yeah, maybe it might be in one of those.
Yeah, probably.
Yeah.
Okay, so here he's showing the burning of the living forms into the wood.
Yeah, this is a very small model of what I had in my laboratory out at RCA in the Marconi,
Right.
which was like a 10 kilowatt version. This was a small little 100 watt, just to kind of show some of the interesting effects of the discharges and that they're organic. That was also covered in the RCA Alexanderson antenna field video, where Tom Brown and I showed that the drainage patterns on the beach were also these fractal golden ratio proportions, which was kind of a surprise that you would find that, but patterns in the wood and all those kind of things were actually occurring with water flow and what have you.
Well, I mean, Stubblefield was saying that you start running these things and the effects just grow in the ground.
This Jerry Vassilatos.
Yeah, that too. Yeah.
Yeah. Well, that was his contention and Tesla also remarked that in operating his Colorado Springs transmitter over a period of time, his instrumentation would indicate that something was growing in size.
Right.
That was coming off of his transformer.
Right. Well, I mean, Bedini ran a number of experiments where he started broadcasting music into the ground using like a Stubblefield type of circuit. And then we could just take two coat hanger wires and stick it, past the bark in a tree and pick it up, anywhere along. And so he started doing this, and what he found was that after he'd been doing this for a couple of weeks, he could find it miles farther in the ground than he could at the beginning. So it was. So there's definitely something like this going on, and that he was broadcasting the AM, or I mean the audio frequency stuff directly into the ground with no carrier, which is the Stubblefield wireless telephone system. There was no carrier in that. The audio was directly transmitted through the ground. So yeah, amazing stuff.
So I guess that's the entirety of the video then, Aaron?
We're here. So here's the part of the cosmic induction generator bulb kind of demo. She did the burning of the wood. I think there was a little flame speaker, and then the bulb here with all the interesting patterns in it.
Yeah. I think that was Chris Carson's machine that he had built.
Yeah.
Thus far, the best cosmic light bulb thing is what we did up there with the Collins and those so-called Rife tubes. The magic mushroom tube. That's the closest we got thus far, as far as video goes, of the cosmic light bulb effect.
Was that presentation called, it was the audio modulator bay? It was
No, this was,
Borderland, the borderlands of,
it might have been that. It was, well, we discovered it, in your shop. And the Collins had put out, barely enough power to do it. That Paul Babcock called it the magic mushroom, because the electrode, I think, was mushroom shaped, and the colors and the shapes were. It was starting to make the Reiki and cosmic superposition, which David and I had done in Bolinas, and we actually got a galaxy once. Of all the years on and off that these things have been attempted, in the very beginning, we actually had one light bulb that just had the magic proportions of ions, and we got a complete Reiki and cosmic superimposition of a galaxy floating inside the light bulb, and then the light bulb exploded, not imploded, but exploded with incredible force. And I've been wanting to duplicate that, ever since then, and that was back in 1978. And
We got some really close to that stuff at the original demo in 1984 at the Integratron when I was there.
yeah,
We got some really wild stuff that day too.
well, what Griffin and I have been working on with his vacuum tube stuff, and what I've learned from Farnsworth, and and I've been doing this stuff since infancy. So there is a way to actually make the right bulb and do this. And also, nobody's ever experimented with a polyphase Tesla transformer arrangement where you have 4 poles instead of 2 poles. So
Right.
this cosmic light bulb thing could really, produce cosmic events inside a light bulb. But unfortunately, to get everything together, what have you, it's just, it'll never happen. It's just, there's no money, there's no help anymore. I mean, you and I are the last of an era. Everybody else is dead. And there's no big money for any of this stuff anymore. And the expense of doing anything anymore, what used to cost $1 now costs, $50 or what have you. When I first started this stuff,
Something I've seen.
what was the price of gasoline? 35 cents a gallon. But I'm endeavoring here, and Griffin's making good progress. But the thing is, to make one tube, going through the experiments and all that stuff, Griffin tells me it took him 20 tubes to finally get the one to produce the Tesla beam.
There you go.
Okay.
This is the exact thing. This is why 99% of people fail, or 99.9% of people fail. They just don't persevere. In the face of what it takes to make these discoveries.
Well, and the skills involved
Right.
also. Making your own tubes is not a simple hobbyist. Griffin's been studying this stuff since he's been 10 years old.
Right.
And, and me similarly. And we have a whole line of tubes that we've conceived, including the Farnsworth multiplier tube that produced the star that was self-sustaining. But this is not something, that just one person can do in their garage.
Right.
And get,
And Lord knows we've tried, right?
Yeah. Well, we produced our first galaxy in David's bedroom when he was in high school.
There you go.
But then we had RCA as our buddy. All we'd have to do is just go 2 miles out to the station and pull whatever parts we needed off the shelf.
Yeah.
So I've done this, I don't know how many times. You've seen the last, well, no, Aaron has a reproduction of the Bolinas coil. And that's what we use the coils off of that to power the cosmic light bulb. So basically it's kind of halfway there. right now, the main problem is who's going to make the bulb. That's the main problem. And there's one element in Aaron's what he's got is what's called the Navy World War II Navy TBM transmitter, which oddly enough uses the meters out of it actually are out of the World War II TBM transmitter. So the power amplifier needs to be assembled, but the low power version with the Collins works, but there's nobody to make the bulb. That's the holdup. There's nobody to make the bulb. You got something there?
Okay. Well, should we go ahead and open up for questions?
I think we pretty much ran through everything.
Okay. Let's see. We'll take questions from Gene Manning first. See, Gene, are you there? Can you hear this? Okay.
Yes.
Okay.
I think it's better if the techie people do it. But I had a question when I watched the video. Are you still going with this terminology that instead of free energy, a better term would be anti-thermodynamic energy, or what's the word, kinetic energy? Do you still go by? In fact, a broader question: do you stand by, Eric and Peter? Do you stand by pretty well everything the way you looked at it back then?
Oh, hell no. We've learned massive amounts since then. But the point is that the environment is the source of all energy phenomena that we're going to have access to.
Well, the proper term for free energy has been so dirtied, so to speak, that the proper term, and this is what I had come up with back in that era, was energy synthesis. In other words, synthesizing energy from its component parts, which would be electrostatic and magnetic potential.
Right. So if you could combine those from two separate sources, then you could.
Yeah, the other would be energy conversion, which is Tesla's idea of extracting energy from the environment. In
Right.
That, the ballpoint pen traveling at 1 million miles per hour through space, hits the tree, and then you get Hiroshima.
or you could do it at a slightly lower level of activity.
A speck of dust.
Right, a speck of dust at a time, yeah. Right.
Okay, thanks, guys.
Okay, let's see. There's a couple. If anybody does have a question, there's a what is it? Tool. There's a React icon at the bottom of your screen. And if you're on a mobile phone, I have no idea. But there's raise hand. So there's a little raise hand button. And if you click that, that'll put a little raised hand icon by your name. And then we can get you unmuted and you can ask your questions. I do have some that were emailed to me. Let's see. So if nobody raises their hand, I'm just going to read these. So Tom Brown says at some point in this video, Eric found in his work that dielectricity is related to what's called the orgone energy,
Reiki and orgone energy, right?
Or what we understand as the mass-free energy of the ether. The question is, what particle imparts momentum in this scenario? Is the torque or spin of the massless ether particle transmuting momentum into another frame of reference?
Okay, that's the question. The thing is that Tesla believed, and he stated over and over, that energy or electricity, even electricity, was the movement of mass. He was absolute. He said that's what it is. And going back to the experiments of Sir William Crookes and the development of the radiometer, demonstrating that even light can impart momentum to the little spinner in the vacuum bulb. So there are two bodies of thought on this. One that the ether is just a smaller, smaller than an electron, but still a physical event. The movement of those types of things. Today we might call them neutrinos or something else, but back in those days, Tesla was sure that there were at least two more gases. If you look at the periodic table, developed by Mendeleev, you see a pattern and developed in one row, and then the pattern is repeated, and that's why they call it the periodic table. That you have a pattern and a repeat, and then a new pattern and a repeat. Well, the two gases before hydrogen and helium are missing, and that's because those gases are smaller than it would take to even have one proton, and that's the point. That because Mendeleev didn't care whether something had a proton or not. He was trying to create a methodology that would simply characterize all mass phenomena. And Tesla, worked with Mendeleev on all that stuff and was very sure that he had found at least two, quote, ether gases before helium and hydrogen. And he thought he had found four others besides that. In other words, the pattern even before that. So, there's.
Well, this brings something to mind in that, like I said, when the galaxy appeared in the bulb exploded, not imploded, exploded viciously. Now, we had observed, I think it happened once in the Santa Barbara laboratory, when we did that grand demonstration where the audio guys showed up and all that, or maybe it was when this guy Fueling came to visit.
Oh yeah, you blew a bulb right in front of Fueling's face.
It didn't like him. So whatever it came alive in the bulb didn't like him. But what had happened in that episode is one of the bulbs exploded. Okay, but the discharge continued to exist in its semi-vacuum environment in free space. And the one thing that was most remarkable about these bulbs, and Tesla observed this also, and so is Griffin in his duplication of Tesla's vacuum tube work, that when this bulb is in this state of excitation and the glass is heated up to the melting point, it bulges out. But there's a partial vacuum in the bulb. So even though there's no identifiable mass in the bulb is now under pressure when it's under excitation.
Right, and that's more than 14.7 psi, because these things push out big time.
Yeah, the bulb will explode, not implode. Now, I had done, in my analysis of J.J. Thomson's work, and I presented this in my presentation, what was it? Power of the Ether. Aaron and I, that's I wanted to make mention to you, Aaron, to get back, and the mathematical part at the very end shows the mass-free equivalent dimensions of the ether. I had, through hell of a lot of effort, deciphered J.J. Thomson's work, which is extremely difficult to decipher because of the method that physicists use to their dimensions and coordinate systems and what have you, almost impossible to work with. But I had weighted them out and came up with the mass equivalent, which would be what they believed the ether to be in that era. Now, the ether, that concept goes all the way back, God knows how far.
Aristotle.
It has an esoteric meaning in that it's one of the steps to creation. which is not what the 19th century physicists believed. In fact, the 19th century physicist concept of the ether was so convoluted it couldn't go anywhere. And that's what resulted in, the reaction against it. It's not physical. And this is what Wilhelm Reich strenuously emphasized. It is not physical, but it can produce physical effects. So it's very unwise to start attaching ideas to what the ether is when you don't know anything about it at all.
But see that this is the problem, is that Reich believed that it was a mass-free energy, but the point is that he would basically say, look, I can charge a rubber glove up with this energy just by having it out in the sunlight, and this is exactly what Crookes was saying. Look, the sunlight has all this stuff in it, and but they were relating it back to mass, whereas so it was an interpretation. The people who said it was mass free are simply looking at some sort of particle that is so much smaller than measurable that they just say, well, there isn't any mass. And
well, there's no reason to even attribute it to a particle when you don't know what it is at all.
Exactly.
And the thing is, and what I've always emphasized again and again and again, physics has no business sticking its nose into the science of electricity. Because electricity is not physical. It may, provide a physical effect or presence, like spinning motors, but electricity is not physical. There's no mass. Okay. The thing is you can't, pour electrons out of the beaker and have them fall to the ground. It doesn't work like that. There's no mass involved there. And this is right. Emphasize this again and again, but all it would do was just inflame the physicist into it. That's all they can think of is mass until it's become, some kind of something that they worship, like some kind of golden calf or something out of the Bible. And of course, that story tells you what the bad effects were.
Aaron,
we can't get anywhere because of the physicists.
Right.
And when we try to use their terminology, the whole thing is self-defeating.
Right. Aaron, you want to catch some of these questions here?
Yeah. Okay, Francis. Go and unmute yourself.
Yeah, can you hear me now?
Yep.
Yeah.
Oh, super. The what is it? The homopolar generator, or the N machine. That video starts at 47 minutes into the whole video. Peter, did you ever figure out why you get an EMF off of that thing? Because originally you're claiming it should all be shorted out, copper winding around it, and the two discs sandwiched together.
Right.
Did you ever figure out why it was giving off an EMF reading on the scope?
Well, this goes, the only reason we actually tried the experiment in the first place was that De Palma wrote a paper called The Secret of the Faraday Disc. And in that, he basically laid out a series of experiments which had shown that if you magnetize different sections of the disc, different potentials would show up. But they would only show up when the disc was spinning. And what he came up with was that the power cross product of the magnetism, the lines of magnetism that were parallel to the axle, would intersect the radial distribution of the inertial field of what we call the centrifugal force. And this created an infinite impedance in the disc. And so that any two locations could produce a potential between them when it was spinning. And that there was kind of a minimum place where this event would show up. But that's the reason we tried the experiment in the first place to see if that was possible.
Okay.
It absolutely turned out to be true that
Did
if you put a resistance meter on the disc when it's not spinning, it shows 0 ohms, obviously.
Yeah.
And
Did it actually generate AC?
well, the point was is if you could even produce DC, voltage in one direction and on one location of the disk, and DC, in the opposite direction somewhere else on the disk, then that proved it too. You see, and you see when you look back at like Adam Trombley's end machine experiments, I think that was probably the name you were looking for, Aaron. Adam
Yes.
Trombley. Because he folded the magnetic field back through the disk twice.
In the video, you claim that it generated AC, and on the scope, we see a sine wave.
Yep.
It looks like it's the 0 line is in the middle, and the positive half is on the top, and the negative half of the AC is on the bottom.
Right.
Like it is generating.
It is. No, it's a true AC.
Okay, thank you.
Oh yeah, no, it's true AC. But that's the point that that oscilloscope was seeing about 50 millivolts. Okay, but even to generate 50 millivolts against 0 ohms on the copper disc, it means an awful lot of current.
Yeah, Peter, may I suggest an alternate theory?
Send me an email. I don't know what. But the point is that we didn't ever believe that it was producing EMFs for any reason other than what anybody else ever saw, including Tesla and Faraday and everybody else. So that it produced an EMF was of significance to us. We weren't trying to figure out why.
I believe I know why you got AC out of that and nobody else could. You got AC out of that because it's not a homopolar generator.
No, it's not a homopolar anymore. No.
You have 2 magnets on there, north, south, north, south. Right. Okay, that's a multipolar disk.
Yes, of course.
Okay, well now when you spin that thing, it's going to generate a magnetic field, and if it goes by any iron at all, that iron, it's going to there's an EMF going to be induced into that iron, right?
No, here's the thing. What you're suggesting is that the AC is generated in the brush and the wire mechanism around the disc. We've absolutely made sure that is not what it is. Because absolutely. You can take the wires, instead of putting them on the disc, you can put them right next to each other and hold it up to the disc, and it doesn't do it. So, no. You can decide what you want, but until you run the experiment and prove to yourself that it is doing what we're saying, then it's interesting. But no, it is what it is. Okay, so it's not an artifact of the setup.
It's
absolutely not.
The legs that are holding up the disc, that are attached to the bearings and the shaft. The legs are the solid iron that the rotating magnetic field is going through, and the legs are cutting the lines of force, generating the AC. No. Now that AC gets fed back into the disc all over the place, so your brushes will pick up AC no matter where you place them. But I suggest you try placing the brush, or really just the probe. You don't need the brushes at all. Just put the probe on the metal legs and put the other probe to dirt ground and watch your O-scope. Watch the AC. It'll
tell you what, you do it, because I've done all these things and I know that I am telling you the truth, and anybody can believe what they want. Okay? I'm not here to prove anything. I'm here to report. Okay? So I report that I have tried every way, shape, and form in my lab, to the best of my knowledge and to the best of my honesty. Self-honesty is the highest level. And I'm reporting what I have seen and proved to myself. So anybody can believe anything they want. But I 100% refute your suggestion that it is generated by some artifact outside the machine. 100%. I refute that completely.
So
Okay.
we'll leave it at there. Francis, you're welcome to put a video on YouTube and you can post it in Energetic Forum. And then
Okay.
we'll
Thank
go
you.
from there. Okay. Okay, we'll take another question. Sorry, I don't know how to read this or what your name is, but I'm going to go ahead and unmute you and you can go ahead and introduce yourself, where you're from, and ask your question.
Yeah. Hi everyone. Hi Peter.
If you can
I'm
speak up a little louder, please.
Yeah. I'm Konstantin. Do you hear me well?
Yes.
All right. Great. So hello everyone. Hi Peter.
Hello.
I'm Konstantin from Russia. And first of all, really thank you so much for your research and for your book. That was a really inspiration for me for a lot of years. And my question can be related to the last demonstration on that video, that vacuum tube modulator or Tesla coil. What do you believe is a good way to make a driving circuit for a high voltage triode to commute high voltage and hopefully to produce an electroradiant event? Remember, Edwin Gray circuit had a triode, and you say in your Free Energy Secrets book that the triode is sufficient to give us the impulses to hopefully get radiant energy going. But the challenge is to build that submodulator or the master oscillator to have that high voltage swings at the grid of a tube. So I hope I'm getting through.
Yeah. No, you're getting through there are a number of assumptions in the book. You're referring to the book Free Energy Secrets of Cold Electricity. And there are a number of assumptions that I made in that lecture which have proved to be not true. And this was a friend of ours here in Spokane, a guy named Mark McKay, eventually went around and interviewed every single person who had ever worked with Ed Gray who was still alive, and got a much clearer picture of what was happening there. I also had a number of very deep conversations with Robert C. Beck, who interviewed for the job that Richard Hackenberger eventually got in working with Ed Gray. And so he had tested the engine extensively too, and he had some different ideas about why it worked as well. So it's I have stopped looking into that engine. I came to the conclusion that the power supply was the most important thing, and that the motor itself was an appliance that used the energy gains produced by the power supply. And again, the power supply, if you read the patents, the power supply essentially says that they are synthesizing, as Eric said, they're synthesizing more watts by combining a high voltage discharge and a high current discharge coming up out of the battery, and they're combining that in the motor coils to produce more power than they started with. And this is, what I refer to as synthetic electricity, or building electricity from its components. And that is, in fact, the explanation that is in the vacuum tube patents. So the idea that it comes from a radiant emission from those tubes and other things were the theory of Jerry Vassilatos, is some people still believe that that is part of it. Some people believe that there was a phenomena developed in the commutation of arc pulling. It's still not known what the energy generation process was in that engine. And since I didn't have anywhere near enough money to follow up on it, I've pretty much abandoned it as a path that I have been interested in for any. I mean, I wrote the book 25 years ago, so yeah. So I don't know that. All I'm saying is I think unfortunately you're kind of on your own. If you want to understand how to build circuits the way that'll do what you want, Eric would be able to talk to you about that type of circuitry. But yeah.
This tube, that gray tube or whatever, it wasn't just a conventional thermionic electron tube. It was something. It was unique, and I didn't pay much attention to that stuff back then, but it wasn't something that RCA made and you could just hook it up differently or any of that. And it's always been my philosophy when I got engaged in this stuff is when something becomes so enigmatic that you can speculate forever. I'm just simply not going to waste time and money on it.
Right. That's pretty much where I ended up too.
That's a more efficient way to operate, because that's what most of this stuff is you can just speculate and postulate and and what have you, and nothing ever comes out of it. In fact, back in the day, when Tom Brown and myself had joined together to debunk, most of this stuff and get the residue off the bottom of the beaker, 1 microgram little bead that was actually, of relevance. It's just, what's the point in speculating forever? That's for the Einstein crowd, where they just speculate and fantasize, and then one theory corrects the other until eventually, as Tesla said, it loses contact with reality. But people want to be entertained, and it's entertaining to speculate. But if it doesn't produce horsepower hours, then it's not economic.
Anyway, I'm not trying to discourage you from your researches. Something happened there that a lot of people believed was important in the day, no doubt about it. And but I have started looking at much simpler methods of if the method of energy gain in that system was related to the circuitry and not the engine itself, then then we're looking at a different set of inquiries. So and I'm still very interested in the possibility of what I call synthetic electricity. And I have demonstrated being able to take voltage from one source and current from the second source, combine them in an arc, and run that through a transformer and light a light bulb on an isolated winding on the other side of the transformer. So I know it's true. You can create more watts than you start with, if you do this right. And an economical way of doing it has not shown up yet.
Uh-huh.
Okay, we'll take a question from Sarkis.
Hey, everyone, thank you for this great event and very, very informative. I have a question in regards to what Eric was saying. There's not a lot of people like you these days, like
There
Peter.
weren't ever, there weren't ever anybody like him. You know, it doesn't matter what year it is.
That's yeah, and my question is, do you guys consider like having some sort of a learning platform where you can get the kids onboarded, and it could be paid, and like they could pay for the teacher's time, could be like non-profit or something, but just to get that, prep that generation in order for us to, as a civilization, to produce more people at least close to you guys, that we can get progress even faster when you have more people in the same mindset and knowledge and everything joining. And I'd be happy to volunteer in this. I can build out a university platform and donate, as a donation. Like I wouldn't, I will volunteer my time. But there's books that Eric wrote, algebras and a lot of great stuff. I mean, that's a really great learning. There's a base there, in other words, and it could be initiated somehow.
Here's to do something like getting together with Zoom or all that. I don't know. That wouldn't really.
No, not like that.
Here's my situation. Okay, since Philo Farnsworth got me started on this back in 1978, when I had no equipment, it was all gone, everything got bulldozed, and he was the one that, okay, let's approach this mathematically. You need to start writing papers. Well, as you know, I've been doing that for a long time. Okay, sitting right here in this room, I have thousands and thousands of pages of finished material. I produce one finished book every 8 months. You know why you don't get to see them? Because there's no money to have them transcribed. Yeah. Every day, I spend 4 hours every day religiously writing books on polyphase power, writing books on, musical and Pythagorean type of mathematics, on and on and on and on. I've been doing this for decades. I've translated all of Steinmetz's important works. I've translated all of J.J. Thompson's important works, the whole thing. Right behind me, if I move out of the way, there's a shelf. It's all just sitting there gathering dust because there's no money to get it transcribed. Who wants to come up with the money to get the works transcribed? It's expensive. And a lot of things going on here are expensive. I have miles and miles of poles and wire out in the desert. I've got mines with seismographs and sensors in them. I have a big industrial building in a town. I'm a public utility in that town and all that. Just keeping that going is an inordinate quantity of money. And now what I want to ask for more money to do something else, and then how do I manage the finances? If somebody donates a significant quantity of money, do I just put it into any project that's high on the priority list, or are they providing that money to do something like get the books transcribed, and then it becomes a problem? Okay, well, who's going to manage that? You see what I'm getting at here?
Yeah, I understand that.
Frustrating, So basically, it's just like the days with Philo Farnsworth when I was a feral human and I just ran around in the woods barefoot with a notebook underneath my arm, devising equations to represent electricity and what have you. It's just I'm just entertaining myself. It is fascinating. I learn all kinds of things and, develop new equations and new understandings of electrical phenomena. And it's quite satisfying. But how do I get this out? That's kind of what you're requesting. And then, you know, Peter and myself are both essentially retired. So I don't know how he would want to move forward with something like that with his knowledge, but this is kind of what we're up against here.
So, Sarkis, I hear you, and like a school type of online model is actually something I've been wanting to do for a long time. It's not it's not a priority right now. I have to get through some product development projects first before looking at anything like that. But within all the books and videos that have been produced, over 200 of them available on eMedia Press, there's enough material there that there's enough to extract out of all of those in order to create a curriculum for different people at different levels for different topics.
Mm-hmm.
So a lot of the material is already done. It just needs to be pulled out, put in a right order, and but it is something that I'm interested in, and you know, specifically with schools and children and so forth. I've volunteered multiple times with, you know, one of the local public Montessori schools and stuff, and doing, you know, showing them the solar charge stuff using some of the Bedini chargers and having them hook up a little, you know, system on the campouts and lighting their, you know, lighting up some bulbs and even lighting up or powering all the audio stuff off of a battery that they charge that day for the talent show and that kind of stuff, right? So I am interested in that. I even have a draft for a children's book for some of the different basic little projects, you know, dealing with the Bedini SG and some of these simple little things. But yeah, I mean, at some point that's something I would be interested in exploring.
Okay, sounds good. And another thing that I wanted to mention is I've been fascinated with Reich and his orgone accumulators, and so I've been building these things. And you know, if you guys need a orgone accumulator box, I'm willing to donate one if you want to have it for research or whatnot. I even built one with the layers that have each layer coming out with a copper out, so you can feed some voltage into it on the layers, just as an experimental thing. But just wanted to throw it out there because I heard you talk a lot about the life force energy and Reich, and if I could be any help, let me know.
Okay, appreciate the offer.
Well,
Thank
from
you.
what you were saying, Aaron, you know, basically all the presentations that I've done, you know, in collaboration with you are the textbooks on the subject, done on a very popular level. So visually, there's a lot already done. I mean, each one of those presentations that we did is, you know, a PhD thesis. I mean, you remember how much work some of those things were to put together. It almost burned out your computer one.
Yeah.
So, and I seen somebody was asking a question. When I say transcribed, is all of this stuff is handwritten here in notebooks, and right now Griffin's the only one doing the transcription, but he's got plenty of other things to keep him busy. Is that needs to be turned into text, and then that text then needs to go into the publishing route, which you already have control over. So basically, the problem is getting the handwritten material turned into text in some digital form so that it's available, and then that gets transcribed in the books. Now, as far as doing, you know, these ebooks and things like that, I find that people don't really want that. They want the hard copy. There's something wrong about digital. And that's what's causing this massive societal collapse that we're experiencing now, where the human race has completely lost contact with reality. That is because of digital. And people basically, they want something they can hold in their hand and not, you know, to be bent over, you know, turtleneck in front of their computer screen trying to read this stuff. It needs to go in the books. But that is a self-financing process, because the books sell and Amazon does all this stuff now for virtually no cost. What costs the money, and it always has cost the money, and it costs a lot of money, is getting the handwritten material turned into print.
Let's see, what time is it here?
It's 20 after
2:20.
2, yeah.
Maybe we can stop in about 10 minutes.
Got one more question here.
So, okay, we'll go ahead and move on. Kimesh, go ahead and you can go ahead and unmute, introduce yourself, ask your question.
Great. Thank you, Oren. Kimesh from Cape Town, South Africa. Firstly, thanks so much for interesting discussion, Peter and Eric. My question's about the homopolar motor. I saw a video with William Line some time ago in which he describes a story about some old vintage Tesla energy meters which he somehow connected in his apartment and managed to blow the main circuit breaker in the building. And I was wondering whether there's any similarity between the vintage Tesla energy meters and the homopolar motor. Not sure if either Eric or Peter are aware of this story that William Line describes in one of his interviews. Just be interested to know what might be special about the old Tesla energy meters that are normally used to be used in the domestic environment for measuring energy consumption. I'd appreciate any comments you might have.
Well, those meters were not invented by Tesla. They were invented by somebody called Schallenberger for Westinghouse, for the Westinghouse Tesla system. And unfortunately, William Line had a very vivid imagination, even though he was very instrumental in getting me much more interested in the J.J. Thomson than I was originally. And from him and Jerry Vassilatos both share the same coordinate system, so to speak, in that their material is very inspirational and it kind of inspires you and gives you kind of the framework of the language and things that are going on. But as far as any actually specific physical event or specific interpretation, you have to be really careful with that stuff. You have to read between the lines.
And run your own experiments to make sure that your interpretation of what they're saying has the validity that you're giving it.
So, because I remember that William Line had actually given a presentation at one of Aaron's conferences.
I think two. Didn't we come to two?
Yeah, there was a couple presentations.
Yeah.
Tesla's Ideal Flying Machine, and then I think one other.
Yeah.
So he had mentioned something about what he had done with the disk induction type of electrical energy meter, and it sounded absolutely preposterous. And at that point, I didn't really hold much credence with what he had to say after that point. So I think basically there's nothing really happening there.
Okay. All right.
Yeah.
Okay. I just wanted to confirm whether I should take that further or whether I should just try my own home polar motor experiments. Yeah.
Yeah, I found it's best to, you got to go back to the beginning, which is, like from the 18th century to the beginning of the 20th century. And then once you're in the middle, into the latter part of the 20th century, you pretty much have to disregard. It's all regurgitated or fantasized material from prior epochs in history. It's always best to, I've learned more about things going back to Pythagoras as far as abstract mathematics goes as anything I would get, that was written today or in our era.
Yeah. Anything after World War II is absolutely a toss away. Just throw everything just went to commercial trash.
Yeah.
So
And you could say the same thing about after World War I. So, I mean, this stuff, it moves it in like, layers. So like, my contention is as somebody that's very involved in music that I call 1970 the day the music died. And it did. When music turned to garbage, and now whatever people call music is just some sickening. I won't even use my characterizations for it because I'm sure it will offend everybody. But then, as somebody, me being a creature of the 18th century, I would also say that the day music died was 1750 with Johann Sebastian Bach, because when Bach and Handel died, that was the end of power music that actually had power, force. It could make things happen. After that, it just became a bunch of dreary delirium and cutesiness of, poodles dancing for cookies on their hind legs. And then modernism came in, and it just sounded like this, it became the sound of torturing animals and other shrieks. And today, it's just been reduced to humping and slapping.
Well, you're still looking pretty good for, 200 years
for
old.
being 250, yeah, really, you're hanging in there, Eric.
Thank you, gents. Thank you so much.
Okay, thank you. Let's see. I'll just ask a couple more questions here, and we'll go ahead and wrap it up.
There's a question about counter space. The term counter space was Wolfgang Goethe was the one that coined the term counter space. Somebody
is that a question in the chat?
Yeah.
Oh, okay.
And that was promoted heavily by Rudolf Steiner, and to some extent, a very limited extent, in the latter writings of Charles Steinmetz. And that's where I got the term from, and then applied it to my work with electricity.
Okay.
Doesn't Ernst Blair's Matter, he discusses counter space too, doesn't he?
Maybe, I don't remember.
Okay.
But that's all kind of the same crowd. They all revolve around Goethe.
Okay, yeah.
They're all the Steinerians.
Let's see. One question. What do you want, volts or amps? So in the video, Eric said neither of these. Eric said neither of these things are electricity. One is the law of electromagnetic induction. The other one's the law of magnetodielectric induction. Neither is electricity. That's why we've incorporated the electrodynamic instruments here. We'll take the product of both the so-called EMF or volts and current or amperes. This is what Eric said in the video. Could Eric explain a little bit more about A, which devices are used to effectively measure the distinct sub-phenomena volts, amps of electricity, and how are most EEs misled by their assumptions informed by the standard model scientist theory of electricity?
Well, that would take about an hour.
in the 3 minutes we have left, really.
So I'll quote Steinmetz. The volts and amps are mathematical abstractions. So what Steinmetz regarded as the kernel of electricity is what I call the Planck. And that's volts times amps multiplied by time squared, or energy multiplied by time, or what have you. So basically, if you take the product of the dielectric induction, which is the number of lines of force in the model, so to speak, and you multiply that by the total number of complementary lines, so the dielectric on one side, the magnetic on the other, then that gives you the dimensions of electricity. You take the time rate of that, and that's energy, and you take the time rate of energy, and that's power, and then you split the power in half, and that gives you the volts and amps. But then the problem is there's two types of volts and there's two types of amps. I get into the presentations that I've done with Aaron. I get highly involved in that stuff. So from the educational standpoint, notwithstanding me publishing any books or any of that kind of stuff, is that presentations that I've given, I belatingly over and over again describe how, that it's a modern day idea that, that volts are just simply volts is doesn't make any sense. And that this amps and that amps is so I have got one book out. It's called what is it? It's the Heaviside sequel. What's it called? The law
Law of electromagnetic.
uh
Something about the same title that Heaviside had.
yeah, same type of Heaviside use it, the electromagnetic induction and its propagation. That puts all these things together. It's in 3 parts. Of course, it's mathematical, but the mathematics involved is nothing more than, in my era, you would get out of a high school education. Of course, in today's world, a high school education, I wouldn't even want to utter in public what they probably teach you. I'm sure you can see plenty of it on YouTube. It's a big social issue right now, what people get taught in school. But high school algebra, I get into what constitutes volts, what constitutes amps, what constitutes power, what constitutes energy, what are the lines of forces, and how do they all fit together. So basically, this electromagnetic induction and its propagation is a complete course in electrical engineering that has come up with engineering formulations that you will not find in any textbook that's ever been written. And then there's a prelude to this, which is what I wrote living in my car in a state of destitution in Lone Pine for a couple of years. And that's called the Common Language for Electrical Engineers. And that's where I kind of write it in like, for children type of deal, where it's like parables and stories and insults and things like that. And that basically, that's a good place to start. Is let's see, now this one's got a different cover on it, and it comes under different titles.
Yeah, this is the ebook.
Okay.
This is also available as a paperback on Amazon. Only part 1 is available as a paperback on Amazon. Realized recently that part 2 is not a paperback on Amazon.
So basically, part 1 is getting down to business, and part 2 is various slurs and insults and irreverencies to irritate the people that have screwed everything up. But in that second part, there's a lot of experiments, and there's a lot of formulations and kind of I don't know what the word, laissez-faire expose of electricity with various insulting stories and what have you, that I'm sure that some people would find comical and other people would become enraged. But the first part gets down to business, in that we're going to start off knowing nothing, and in the end we're going to come up with what's the finale here, what is the general equation that defines everything we're going to deal with. And then also there was a video presentation, I believe under the same title, which ended with a piece of music by Handel. I forget which one that was called.
Was it Fortescue?
No, not Fortescue. That was the Bach, but the Handel one was Heaviside. It might have been electromagnetic induction and its propagation. It was,
okay.
Yeah, there you go.
Yeah, so it was that one. Okay.
Yeah.
Same one we just showed.
Now, mind you, these are all mathematical, but the mathematics is very elementary. So as Heaviside once commented, well, if you don't want to be bothered with elementary mathematics, then don't bother at all. That's my philosophy on it.
Yeah, the only thing I would like to add to that is some basic experiments that John Bedini and I ran when I was working with him in 2004 and 2005. And he has some very simple self-oscillating circuits that if you put a voltage on it, it just starts oscillating and kicking out these inductive collapses, and runs on a single transistor. And these things, just very, very simple things. And we would put these things on a solar panel so that they would charge a battery, anytime the panel was putting out one electron, this oscillator would start pretty much. And what we saw was when you put the output of this on an oscilloscope, what you see is that the manufacturer says that the transistor has a minimum junction voltage of about somewhere around 0.7 volts or something like that. In other words, it stops conducting current at 7 volts. But when you put it into one of these self-oscillating circuits, what you see is that the oscillator is running. Let's say you put 25 volts on it, and it's charging a 12-volt battery, and it's just oscillating away at about maybe 5,000 cycles a second or something like this. But as the voltage drops, the oscillation rate starts rising. And when it gets down to 0.7 volts, you would think that the whole oscillator would shut off, but it doesn't. And what happens in the waveform is that it just starts putting out voltage spikes that have no current associated with them at all. And that continues all the way down to 0.4 volts, at which point the oscillator shuts off. And so we always, so there was always a width to the output of the impulse above 0.7, but there was no width to the oscillation between 0.7 and 0.4. And this is, we looked at this as proof that there was at least two particles or two phases of electricity in the flow, but both of them would run the oscillator. But of course, the classical understanding was that it wasn't passing any energy after that, but it was still oscillating. The oscillation rate went up to like 20,000 cycles a second, and it was enough. There was enough induction in the winding to turn the transistor on and off, so that there was something there, but it was below the capacity of the system to pass any current. So this was one of the more interesting things we found that suggested that there were at least two components to standard electricity, and that they could be separated and demonstrated independently under the right circumstances. So
there are definitely other forms of electricity that have not been explored.
Exactly.
And that's what, in one of my writings using J.J. Thomson's formulations, and this would explain a lot of what Tesla did and Tesla's philosophy on what he was doing. And there's another type of electricity that flows in conductors that does not involve electrons.
Absolutely. It's
an ether current. And from the standpoint of skin effect and Heaviside and Steinmetz's analysis of the skin effect, is electrons do not conduct electricity. Electrons eat the electricity up. In a response to the electricity that exists in space as it intersects the conductor, and that's when you get, your EMFs and all these things that they talk about in theory. But there's another type of electricity that does not require a closed circuit. It is not circuital, and it's not repelled by the conductor. It's drawn in by the conductor. And this type of electricity is never talked about at all. And then when
Because you can't meter it, and if you can't meter it, you can't sell it.
well, you can't meter it with the meters that the
That they
meters
give you,
we have. Right, because the meters that we have, there is very seldom do you actually have a real voltmeter. They're all amp meters with a ballast resistor or a multiplier resistor or something that proportions the current that the meter responds to the voltage, and then you calibrate the current meter to volts. But if it draws current, then that's the end of volts. So when you say meter, well, you know, you're metering one thing, but then you can't meter, you know, something else. So these other forms, and then Wilhelm Reich, you know, what he was developing and experimenting with was another type of electrostatic field that was alive. And just like we're talking about these homopolar machines and all that, we're talking about another type of magnetism that we don't know anything about. Just because we have all these theories that say, okay, we got lines of force and we have this and we have that, doesn't mean that they have any validity.
Right, it's a model.
They're just simply models that we use to visualize things. That's why as a practicing engineer, you know, and on a research level, I have to discount all theories, because all they're going to do is they're just going to trap me in some idea that may have no connection to reality whatsoever.
Or you won't know when you run an experiment that has nothing to do with the model, and when you try and shoehorn that into the model, then you lose track of what you're actually looking at.
Yeah, then you have, you know, the paradox or the anomaly, and that's what physicists like, because then they can swarm around it like ants around, you know, a sugar cube,
Right.
all wrapped up into, you know, the paradox and the ooh and the ah, you know, and roll their eyes back and wave their hands over their head and talk
Exactly.
in tongues.
There are no anomalies. Hey, there are no anomalies out there. There are just phenomena that haven't been explained yet.
Exactly.
Every experiment you run is a question you're asking of the natural world, and the result of the experiment is nature's answer. And nature never lies to you. So that's the methodology we use here.
Well, that's why the people that made the greatest discoveries always were in very close contact with nature. You know, I mean, I've lived in my Toyota Corolla for 38 years in the wilderness. I was a feral human with no car for a decade. And Steinmetz wrote all of his books in his Toyota Corolla, which was a canoe.
Canoe? Out on what, Lake Champlain or something?
And he would disappear, you know, he'd piss him off, and he would disappear into the bushes, and they found he had a tree fort, you know, and his little canoe. They'd have to, like a trip to the Amazon to look for some rare species of creature, you know, where's Steinmetz?
Well, he's out catching breakfast. What do you think? You know, he's
That's
doing
where he
in the
wrote all his
canoe.
books.
Right. Yeah.
All right. Well, we're at almost 2 hours, 45 minutes. John, sorry, I'm not going to be able to get to some of these other questions.
Well, it could go on all day.
Yeah.
Yeah, that's the problem. So we
So,
gotta,
hey, are you guys open to doing future calls on any of the other boards?
it's too early to say yes to that, Aaron. You know, who knows?
I'll ask you later. So, one upcoming book, the next book for Eric that's going to be coming out will be on Tesla's four quadrant theory. 2023, he presented on Tesla's four quadrant.
Four phase.
Four phase system. There's a part one book that's already out. And then as soon as I can get it from Griffin, part two will be coming out. It's really intended to be one book, but when that comes out, since people have a paperback or the ebook of that so-called part one, we're going to initially release it as a part two, which will be separate. And then maybe after a few months, we'll combine it in one book because it's meant to be one book. So stay tuned for that. Again, join Energy Times at emediapress.com/Energy Times. That's where all the announcements for all this stuff goes out. Any final comments or words, Peter, Eric?
Thanks for putting this together, Aaron.
Well, thank you guys for being on the call. Yeah.
Let me make one final comment. So there's two video presentations that I did in association with you that get right down to the very core basics of electricity. One was the extraluminal systems of I forget the exact name.
Extraluminal transmission systems of
Alexanderson and Tesla.
right.
And the other one is the one that I think is that most people would really like. There's something in it for everybody, from the most advanced engineer to somebody that's never even talked about this stuff before. And that's the history, theory, and practice of the electrical utility system, I believe is the title for that.
Right.
And then there's one on YouTube, which goes by all kinds of different names. There's actually two of them, but there was one that was basically one of the first types of these presentations that I ever did in association with a good friend of mine who lived near Bolinas. And that goes on for like about 4 hours. And it gets into, it was inspired by a book called The History and Theories of the Ether by E.T. Whitaker. The primordial volume, which is hard to find because the ones afterwards were modified to suit his peers. They didn't like his book on the subject. But I don't know what that video is titled of, but it's all over on YouTube. And we nicknamed it Explosion at the Shipyard because there was a parable in there. But that one covers the whole theoretical end of, how all the equations came about and, who discovered this when and what have you. But the history, theory, and practice of the electrical utility system and the extraluminal, those two have extensive chapters in them that deal with the hardcore basic fundamentals of electricity, getting the whole thing cleaned up and set back on course again. So I would say for the beginner, those would be good starts amongst the previous books that, the 4 that I had mentioned regarding heavy side. That's a whole college course right there. You're looking at 4 years of your life.
Yeah,
Okay.
without the expense of a tuition, really.
Hopefully Zoom has enough room to save this call. Okay, well, we'll go ahead and wrap it up. I'll put out any updates. If there's going to be more calls like this, we'll definitely do some more with EPD Labs and the whole EPD crew on other live Zoom calls. And we'll see you on the next one. Thanks, Peter.
Yeah, thank you, everyone who came.
Thanks, everybody, for
this is arcane stuff, and thank you for being interested and wanting to take this stuff further. Really appreciate you guys being here. All really.
Okay,
Thank you, guys.
see you guys.
Anytime, all the time.
Take care, everybody.
All right, take care.
I'm
Thank
sure-
you. Thank you.
Thank
Bye.
you,
I'm sure we'll
everyone.
do
Thank you.
more.